Hey programmers, welcome back. Right now I want to walk through a JavaScript solution for this fib problem. So I'll jump right in over here. We want to solve this one recursively. Just like we said in the approach video, we'll start with our base cases, right? The 0th Fibonacci number is 0 and the first number is 1. So we'll start hammering away over here. So pretty straightforward base cases, right? So if n is 0, then I'll just go ahead and return 0. And on the flip side of that, we'll say if n is 1, then I'll just go ahead and return 1. So this will be our base cases. And beyond that, now I want to handle the actual recursive case. So for now, let's just implement the brute force because it's a reasonable stopping point before we hit the efficient solution using memoization. So the nothing fancy solution would look something like this. You can just return the sum of fib of n minus 1 and fib of n minus 2. So something like this. And we already kind of foretold that this is going to have an exponential runtime, which probably won't pass all of our test cases. So we'll give it a shot. Should be able to run a few of the tests. So we pass at least 7 so far. Looks like we fail the 8th test due to a timeout, right? So this is pretty good because I noticed that I'm timing out. I'm not returning any incorrect answer. It just took too long to actually run here. If you look at the actual test cases that they're going to run for this particular problem, it looks like test 07 is the 46th Fibonacci number, which is apparently not going to work out because of our exponential runtime. All right, so now let's actually fix it. And to do that, we're just going to add our nice memo object. So for all of my JavaScript programmers, typically you can just use a plain old JavaScript object because that acts like a hash map, right? You're going to get some really nice lookup times. So my favorite way to implement that pattern in JavaScript is to actually add an optional argument. So I'm going to have a memo argument. I'm going to default it to just be an empty object. And the reason I like to have it be optional is, of course, I don't really expect the actual test suite or my top level caller to actually give me a blank memo. So when they don't pass in that memo object, I'll go ahead and create one over here. Cool. So here inside of this memo is where I'm going to store all of my keys as arguments to the function. And as the values, I'm going to store the return values, right? So it's going to be a very canned formula. Let me start by making sure that the full recursion shares the single memo objects using some pass by reference action, right? So basically all of my calls are going to reference this single memo object. Now that way they can share information. So let me start with an additional base case. And this is going to check if n is a key in the memo object. So some really straightforward stuff here. So in JavaScript, I can check if a key exists in an object by just saying if n in the object, right? And if that's the case, then I just want to return its stored value. So for example, I'll say return memo square bracket n. And maybe, maybe you're a little rusty with some classic JavaScript syntax. Let's say I just demoed that really quick for us. So super quick aside, if I had some object, let's say it had, I don't know, a name of, name of Alvin. What's going on here? Name of Alvin. And also we'll say an occupation of programmer. Let's say I did a few things. Let me console.log. I'll try to check his name in OBJ. And I'll do the same thing for my occupation. Notice that the keys of JavaScript objects are typically strings, which is why I had to put quotes around here. So is occupation in the object? Make sure you spell it wrong, occupation. Then also check something that doesn't exist, like, I don't know, age. So I'll just run this as a script, so I'm not going to run the tests. Let's see what we get. So I get true, true, false, which makes sense, right? Name and occupation are definitely keys of the object, but age is not. So that's all I'm utilizing here, right? And of course, if I keyed into any of these objects, you should definitely know this. If I did something like object, let's say square bracket, name, then I would just get back that corresponding data. So Alvin for that last console.log. Nice. So basically just added an additional base case checking if my key exists in my memo. If it does, then just return its stored value. And now the only additional change I need to make is wherever I had my recursive return, so this expression, I need to make sure I store that sub-result into my memo before returning. So it's a very, very straightforward change. I'm going to literally take this expression, so whatever I just returned, and instead store it in the memo. So I'll say memo square bracket n equals that value. And another important thing is I'm just going to use the argument of my original function as the key of the memo, because that's really what I want the memo to represent, right? For this given input n, what is its result, right? And this is the result over here. So not only do I want to store that sub-result in the memo for the future, in case someone else needs it, but I also need to complete the same return. So I'm just going to return memo at n. If you wanted to, you could have also, I guess, saved it to a variable. Just make sure you still return that same value. That way you're not changing any of the actual logic for building a sub-solution. So with that change, let's go ahead and run it now. So we'll give this a little test. Passing, cool. And there we actually ran all of the test cases, and it was a pretty quick runtime. It's what we expect, because we did say that, hey, if you implement this memo properly, in terms of your time complexity, you're going to have a linear O of n complexity. And that's very evident over here. Looks like it scales in a very, very transparent way. All right, so there's our solution for fib. Definitely really try to spend some time implementing this on your own, maybe repeat it a few times. It's a really, really important problem-solving concept that we're going to utilize in the next few upcoming problems.